All right. So hope you enjoyed the first presentation. Gergely gonna provide the second presentation, and it seems like he's not gonna stay between you and the food because he's still hungry. So let's give it a big applause to Gergely from Cheppers. You're gonna talk about immutable infrastructure. Test. Jesus Christ. All right. Let me just take this, put it maybe a bit higher. How's that? How is that? No. I don't have a neckline strong or high enough. Oh yeah, just stand there like for 30 minutes or something like that, and then move around with me. All right. Is that okay? Can everybody hear me? All right, awesome. Okay. So I'm not sure if I can bring the awesomeness of the previous talk, but I will certainly try. I cannot show you these amazing nice graphs though, so I apologize for that. What are we going to talk about today? I'm going to talk about cooking infrastructure. How many of you heard the term kettle via spat with servers? All right, a few of you, all right. So I am going to talk about a little bit about that and how to avoid basically having pet servers. So what are kettle and pet servers? Basically, if you have a pet server, that's something called a named server that you cradle and hold dear, because if it dies, then your company dies. So we don't want to have that. And basically the kettle part, obviously, you guessed, is when you have a multitude of servers, none of them is named, but you can slaughter them one by one or en masse, that's up to you. Depends on how much blood you want or meat. Or, well, let's not go there. But basically, when you can, out of zero, create a server that supports your application or your service in any way without you having to interfere at all, you have a nice cooked infrastructure. So,
yeah.
Van egy csávó, aki különösen creepy is, és ilyen fullápolatlanul néz ki, ápolódott sörszaga van, én kibújtott lassan így, amikor különböző ültet az irodában, így végig mögöttem álltál, hogy így elpakolná. De egy kurva bizonyosan, és a mindig oda, hogy az összes minapra jön. Ilyen Cloudera stalker kb.
Common patterns!
Vagy hogy beküld egy ilyen szívit, mindegy, hogy mi. Nem.
Ja, igen, mondjuk.
Can you turn it off, please? Thank you. So the common patterns of a bad infrastructure are, it's unreproducible. What the hell? Le van mi róla? Nincsen. There is literally nothing. It's like nothing is going anywhere. Yeah. Yeah, okay. Okay. Apparently it was me. Well, all right. Well, I have no idea how I was doing that. It was muted and like, all right, let's move on from my embarrassment. And I killed that too. Okay. So common patterns of bad infrastructure are it's unreproducible. Basically means you cannot reproduce it. And that means once you create it, you probably don't remember anymore how it was created, or there's some kind of configuration that you forgot about because it was created last year or something like that. So you basically create a new one and then have to guess how to get to that state that the old one was in. And it's fragile. That's also a condition because if one of the servers breaks, you cannot be fast enough to reproduce that server and make your service resume in the same old state that it was before. It's difficult to maintain, obviously. These are all related to the same problem that you cannot or do not know how the server works or how it was created. And it has leprechauns. Handmade changes are the worst thing that can happen to a server. Like, for example, even if you cook something, even if you have your servers created by an automated process like, for example, with Ansible or Puppet or any Chef or any other configuration management, still you have people offshore or in any other place that play around with the server. For example, there was an outage, a customer needed something, and then there was a little tweak, and everything is working again, yay. And then you roll out a new configuration, and then suddenly that customer is saying, hey, what did you do? My service is dying again. It's like, I didn't do anything. And then after like a day, you find out that this isn't the first that this happened, and some guy did something to the server by hand, and he doesn't remember anymore what he did. He tries to look in the ticket, but obviously he didn't record it, so that you need to find it out again. So don't do that. That's a bad thing. Don't do that. And then too many why is this here? What does that do? Basically, that's the same stuff. You don't know how that got there, who put it there, and why. What purpose does it serve? And that's where I like to do random events of destruction and like remove settings and then see what happens. Doing that on a production server can be fun sometimes. So how not to cook? In this moment, to anyone, if you have a laptop or have production access right now, wait for it. I will give $10 to someone who here right now shuts down one of his production servers. Like literally, just shut it down. And then see what happens. If you get paged, you don't get the $10. So I give you until the end of the talk. If you manage to do it, then $10 is yours. Without any consequences, obviously. So Gordon Ramsay would say, would be sad, I can't read, if you use various recipes, it's still bad if you have a server that is cooked or created in 2 different ways, and some of your stuff is in Puppet, some of your other stuff is in Chef, and some of the other stuff is in Ansible, and you have to like, all right, do I run Puppet or Chef now to produce this and that log or that and that directory or this and that application on my server? I have no idea. I lost track. And that's why I say, yeah, don't do any of that. If you overcook it, your infrastructure code is too complicated. You have a chef recipe, which is 1,500 lines of Ruby. Don't do that. Or you have an Ansible cookbook, which is 1,500 lines of YAML. Don't do that either. For God's sake, do not do that. That's true. But still, don't do that. All right, so though that's how pizza was made. I have no idea what reference that was, but it was a good one, so just go with it. And then, oh yeah, I remember. So if you put together certain things that you got from certain places and then just paste it all over the place and then try to eat it, doesn't taste so good. So then you get AWS and GCP and any other cloud services that provide you with many very nice capabilities. But I'm an AWS guy, so I'm going to go with AWS. A little history. I shared that already, so I'm going to spare you another rant on basement servers and this guy. You don't want to end up like that. Early in the morning at 1 a.m. That's not in the morning, but for some people it is. So early in the morning at 1 a.m. you get paged that some of your servers died, and then you go there and then say, all right, which one was it? Was it you, Greg? No, it was Stanley. No, it was not. Damn it. Where's this cable going? We all been there with basement servers. And then AWS all lifted that up from us, from our backs. And we cannot think which server was it. I have no idea. I have 1,000. And it's a different problem, but you get logs, very nice logs, and you can find out more which of your servers dies. But most of all, you get the diversity of it. So then, bad usages of AWS, we all know that. You go from having a server to a single monolith EC2 instance. EC2 is a VM server in AWS. Who doesn't know AWS? All right. That's gone. Just checking. So you get a single monolith EC2 instance. And that's not good, right? Because you get into the same problem, it still dies. But at least you are on AWS. So many people use AWS just to fire up servers and then have their firewalls on an EC2 instance, which links to another EC2 instance. And I'm like, this is good practice. No, it's not. So you don't have any VPC, you don't have any security groups, all that jazz that AWS does very nicely for security, you don't have that. You have an EC2 instance, you have a public IP address, and then everything runs on that. That's not good. And it still doesn't use any configuration management, so you don't know how it works. Better, still a single EC2, but it's managed by a configuration management system of some kind, even through AWS or Ansible or Chef. But still no VPCs, no security groups, no real single view of how many components there are. A good one, we get progressively better by adding load balancers, auto-scaling groups, VPCs, security instances, all that jazz, which is nice, and you have IAM roles and security setup, which is awesome. But the perfect thing to do, if you do not do any of that by hand at all, ever. So, enter CloudFormations. At this point, CloudFormation, when CloudFormation came around, Terraform was already a thing, and it tried to do the same thing as CloudFormation does right now by combining all of the various services into a single massive configuration file, which is damn ugly, but it works. It's nice. Terraform is nice, but CloudFormation is slightly better, in my opinion. So, Go AWS. No. I don't get paid for that. All right. So what is CloudFormation? Basically, you give it a massive JSON or YAML file, which describes your architecture, including all the IAM roles, all the jazz that I talked about previously, auto-scaling groups, load balancers, everything is configured to CloudFormations. Why is that nice? Because it handles them together. So, once you have all those together, you can create or destroy every one of the individual things that it has, but you can create or destroy them together as well. So, for example, you fire up an instance of your service with a nice CloudFormation stack. You try it, you are confident that it's working, you have the VPCs and security groups together, and you try that out in dev with obviously less resources. Works very nicely. You just basically change the account you are running it on, which is, for example, from that pod. You change the account and fire up the same stack, the descriptor, just with different parameters. For example, more resources, more EC2s, a different auto-scaling group handling, and so on and so forth. But everything works the same way as it did in dev, just with different scales. So then you get to Furnace, which is a thing I wrote. I wrote it. So there you go. It's a very lightweight wrapper around this CloudFormation, because what CloudFormation lacks is a nice enough tool to manage it. To create it, you have to give it like a huge file, and then you have to use the AWS CLI or some Ruby code to like handle that file. You need to validate it, and it doesn't work. Then you need to validate it again. You need to change it. Nobody tells you that it's not how it's supposed to work, and then you fire it up, you wait. It doesn't work, you delete it. So Furnace handles all that for you by giving you simple commands like create, delete, status, and update. That's another nice thing with CloudFormation. You can update your stack. If you're not happy with the auto-scaling group configuration or load balancer configuration or something like that, you just change the setting in your JSON file, and you say update. And magically, your infrastructure, hopefully, gets updated correctly. So, yada yada, Furnace config. You can check it out on GitHub if you're truly interested, but it's not the focus point here. Yeah, you get create, you get push. Oh yeah. Why would you do that? Because if you have an application that you would like an infrastructure for running on that, you can use AWS's code deploy, which all works together nicely with CloudFormation. So basically, you create your infrastructure, and then you use Furnace to push your code onto this infrastructure to test it, to test your service or application. It can use GitHub, it can use S3, it can use any other stuff that you want to push your Bitbucket or whatever. Everybody uses GitHub now, or GitLab nowadays. And deploy your code there and test it, and it will work the same way in production as well. So that's a nice thing about that. You can use multiple Furnace files, which basically means you have multiple stacks with various versions. And then you get into the nice place of, oh yeah, it supports plugins, pre-create, post-create, all that with your plugins. Very nice. It's nice. It's nice. But the nicer thing is, in this talk, I realized that many of the people still who know pets, who knows about pets and cattle and about infrastructure, they still have one thing though that's named. It's the bastion. So if you happen to have customers for which the service you don't want to access directly, for obvious reasons, you probably have something called a jump box or a bastion, which handles your, which is a preliminary server which you SSH into, and then from there everything is configured and you SSH forward into the customer servers if you happen to work in hosting, for example, and you want to see what's wrong there. So the bastion is special. It probably set up by ops people and managed by ops people as well. They create users, they manage the SSH keys and access and everything like that through various things. They go in there, they modify the authorized keys file and create your user and do all that by hand. What did we say previously? Don't do that. Don't do it by hand. So Bastion is still, user management is still a pet peeve of many people, and it's very hard to come by, even though you have like various services that do that. So for example, in AWS, you have IAM, which IAM roles and IAM users, which basically manage users for you, and users can have public SSH keys. So what if I told you that even your Bastion could be serverless for a server which is fired up upon request when you need to like log into a customer's account, server. Minor detail. Server, you want to go to your Bastion, and if you don't happen to do that too often, then it's beneficial to have it as a serverless Bastion intermediate. Basically, Lambda can do that for you, or any other service. Right now, I'm just going to assume it's an EC2 somewhere. So the nice thing of that is that with IAM-based roles, you don't have to keep track of who has access to what and why and any of that shebang, because then you can create roles and groups in IAM. So for example, you have multiple products. You have product 1, product A, product B, and some of your users are in the group product A, and the other users are in group product B. Obviously, they can access some of the services, some of the servers in each product. So how do you do that, though? You do not want to touch your Bastion. You just want people to be able to SSH in, even though they are not registered on the server. You don't touch the server, but get their roles and public SSH keys out of AWS. Somehow the server needs to know that they have this public key. They did send that public key along when they tried to SSH in. You compare the two keys, and then you compare the groups, and then you get what kind of permissions do they have, and then decide if you let them in or not, or if you let them in, how they can proceed from there. But you do not want to do any of that by hand. So how do you do that? There's a fairly new and interesting thing called authorized keys commands. Authorized keys command. Who doesn't know of it? Ooh, nice. Basically, it's what it says. It runs a script before for authentication. Instead of using the authorized keys files, it runs a script that you define, which has to provide you with a set of public keys that it can compare to. So, and this guy has a bunch of tokens that it can get. So in your SSH config file, you say, all right, so my script will get a username, a encryption type, encryption key type, and the public key. And you can have a bunch more if you want to make it more granular, but usually that's enough. Why would you do that? I just said that because it can be role-based, and you don't have to basically. You just create a new user in IAM. You put them into a role, tell them to upload their SSH key they want to use, and then they can SSH to Bastion. That's it. You don't have to, you don't have to do anything else. You just let the message into question through the IAM. So what would somebody think of that? Yeah, I still have 5 minutes. But what if you want to do the same? Like you don't want to have 1,000 users in IAM if you have a lot of customers and they all need to SSH to Warrior servers, and you still want to handle those servers through IAM. You have a couple of options there. One could be a single user per customer that they all manage and they all use that together. Or if you have sites, you can have site users, or you can have a OAuth 2 token-based authentication through this script as well, through IAM, all like tied together. All these things work together. REST SSH access all together. Why would you want them to go into the server? You can do that yourself. That's actually a very restrictive view, but still, it's not that far stretched, because basically you want them to push up code, and then your system handles the deployment. So why would they ever want to SSH? I just want to put that single, like, it helps us, that app I saw on Reddit. So, or you can let the customer handle all the accounts for the employees and environment, which is still an option. But all your ops people, though, for 2 Bastion can use this SSH array. Ooh, I wanted to show you code. So, for example, such script, you might say, could look something like this. I don't know if you see. Basically what happens, you initiate the AWS client, four because the 3 arguments are the user, the key tab, and the public key, and for which, when you put those into the SSH command, SSH config will get, this will be getting that. And then you have the client, and then you list all the public keys, and if the response, if the user does have access, actually this would be like way down there, but never mind. If you allow the user to come in, you still have to create the user by hand on the server. So that's an interesting bit, because when the user terminates a session, you can delete the user immediately, making it possible that the user doesn't linger. If everything is like set up correctly, the user shouldn't persist. There is no need for it to persist. You just delete it when the session is over. You can set it up with system D or system CTL through the user slices. You just say, yeah, remove this slice once it's done. That's a very nice addition to it. And then you basically, a very dumb compare of the public key and the key type put together with the key that's coming in from the user's request. If they don't match, exit, which is permission denied. If they match, you put out the key which the authentication process behind the back accepts you to do. Obviously, you can have multiple keys. Here, I'm restricting to max item 1 for simplicity's sake. But yeah, that's how it looks like, a script. And then you can. This is how it looks like when you put it into the SSH config. Basically, you say authorized keys, and you have the script, which is accessible by root. And these are the tokens that it gets: user, key type, and the key. Permissions are set up. This could be nobody as well, by the way. And then it's a bit better. It's a bit better than root, just slightly. And then basically what happens, I have my server here running on AWS. I have a user, which is whatever, Scasso. And then I say, but the user you can see here is an incorrect one. So we say incorrect. And then it's permission denied. But if I say, like Scasso, yeah, Oh. Sweet, sweet login prompt. Then you can SSH in. Basically, I do not have sudo access because my password is not set up. Yes. So basically, that is all that you need. And you can see, you could see if I had Chrome running, that that user is set up somewhere here. Whew. Jesus. Source, trust me, dude. It works. I'm sorry. And this is all through the power of He-Man. No, CloudFormations. So my bastion, here you can see my user, and that I have, don't try to remember that. I have my SSH key uploaded, and this is the Bastion template file, which is huge as JSON file, and you can set that all up. Basically, once your Bastion is up and running, you can run a user script which sets all that up, and you can your script and the user that the script runs. Can have a temporary access token that it can use to gather the IAM data from AWS. So obviously, you do not set up a script which is omnipotent and can like fuck up your whole system. You give it restricted access only to certain things, like for example, get public data key, get public key, and it's fairly huge. You set up internet access and so on and so forth, but this is the gist of it, basically. Which part? Like this guy. That's a very good question. I put it into a script and run it by hand, and if the output is what I'm expecting it to be, then I'm happy. Otherwise, I'm restricting it to one server only, and then run it through AWS with a nano server, which is the smallest server, and it doesn't cost me any money. And it's fairly quick. It's like a couple of seconds. It pulls up. I remove all the auto-scaling jazz and load balancers and things like that. It just fires it up and see if everything goes. I try to switch in. If it doesn't work, then I have to do some hand tweaking. And that's how I debug it. And I think that, oh yeah, by Furnace, yeah, single binary, blah, blah, blah. It's awesome. Trust me. And that's it. Thank you. Thank you.
Thank you for the presentation. You guys have any questions?
So AWS has this feature called System Manager or something like that. Basically, if you have the agent deployed, the SSM agent, you can use their run command. So basically, you don't need to set up this SSH key magic stuff. The only downside for it that I didn't find any good CLI tool which is actually works like a proper shell and not just giving the results in a JSON format which is unreadable. But do you know anything about that, or did you try that way instead of this as a SSH key magic?
I tried. Yeah, I know about it, and I tried, and I came to the same conclusion as you. That's horrible, and I stopped using it. I actually started to write a wrapper for it in Go, but then ran out of steam doing, and I didn't finish.
Okay, thanks.
Thank you.
I would like to ask you, does Furnace make retry logic during the stack termination? Because one thing why I don't like CloudFormation is that I have to delete the stack more than one time because some resources are broken during the delete and I don't have to, and I have to go back and okay, delete again.
Yeah, it depends on what your outcome needs to be. So, example, Furnace provides you with plugin capability after delete events and pre-delete events and post-delete events. And basically, you can have a plugin that says if you're not in delete complete state, then run this plugin, which basically runs the whole process again. That, and I did dabble with creating the ability to retry a delete, because that's, I know, yeah, it's a possibility that things get messed up. But unfortunately, it ended up in a pseudo infinite loop, because if you happen to run Furnace by an automation process or whatever, like unattended, and you say you want delete complete, but it's a rollback, or a delete failed or something like that, and you retry it, but you don't pay attention, and you end up trying to delete it like 10 to 15 to 100 times, which isn't like maybe something that you want, because the actual problem needs to be resolved by hand. So basically, I left it up to a plugin, because it should be left up to the user if you want to retry it.
So thanks once again for the presenters for spending the time and effort and coming down here. The pizza has arrived. We still have some beers, so please feel free to hang around, ask questions to the presenters. I think they're going to stay, hang around, or anybody, any questions. Enjoy. Thanks for coming.
Thank you very much for having me.